So I think in the last class we discussed about the basic components of an IoT network and how uh, IoT architecture is defined in general, the applications in the industry and in the applications in our day-to-day life. So in today's class, we will be going into the next step. We are going to talk about the physical layer design of IoT. So in today's class, we will be discussing about the physical layer design or physical design of IoT. So in this section, we'll be talking about the physical, components of the IoT networks, basically the hardware and protocols used in IoT. So physical design of IoT is what we're going to talk about today. So basically, physical design of IoT means the design of hardware and network protocols, right? So design of hardware and network protocols and network protocols, network protocols used to collect sensor measurements, design of hardware and network protocols that are used to collect the sensor measurements, the sensor measurements and establish communication between between the IoT devices and the internet, right? Between the IoT devices and the internet, right? So in the physical design of IoT, we'll be talking basically about the hardware and the network protocols that are required for an IoT network based on the application that we are considering, and deciding which hardware is best for our application and which network protocols are best for our application. So like if we consider certain application, we need to design the hardware and the network protocols suitably for that application. So let's talk about such kind of applications. I think we discussed about that in the last class as well. So where we discussed about, like the agricultural IoT network, right? Where we have specific sensors that we use to collect measurements about certain field out in the environment, like for example, a paddy field or some kind of a vegetable or some kind of agricultural field, where we use sensors to detect the parameters of the environment. So we can have like sensors to measure the moisture level of the soil moisture measuring sensor, and then like soil quality measuring sensor. So we can have different sensors to measure the soil quality, and we can actually use a single sensor to measure multiple parameters, or we can use different separate sensors to measure separate parameters. So when we take, for example, if you want to measure the like the temperature, we can use a separate temperature measuring sensor. If you want to measure the humidity level, we can use the humidity sensor, or else we do have the sensors like temperature and humidity measuring sensors that combine the measurements of both the temperature and humidity and give us both those parameters using the same sensors. So we have sensors that can measure both temperature, humidity parameters. So there are such kind of sensors that can measure multiple parameters at the same time. So likewise, those sensors are one of the hardwares that we are using in our IoT designs and in our IoT networks. So as a IoT designer, you need to select which hardware you need to use in your network. So you need to know what type of hardware are already used in the IoT networks, and by getting that knowledge, then you will be able to choose the best items or best hardware for your application. So we'll be talking about the different hardware that we are normally using for IoT physical design or IoT in IoT networks. And we are going to be talking about the protocols or the we call that, standards, right? The standards that we are following, or the standard rules that we are following when we are transmitting data from one location to another uh, uh, using this protocol. So the protocol means the standard rules that we are following during that transmission of data. So we will talk about the network protocols in a late instant. So first of all, we will discuss about the hardware components. If you have any questions, you can let me know. So when we talk about the physical design, as I mentioned before, we have basically two components. In the physical design, we are uh, we are dividing the physical design into two components: the hardware component and the protocol component. The hardware component we call as things, Internet of Things. In the Internet of Things, we have the word things. So things means this hardware and like the components that we are considering in our IoT network. So hardware or things, and the physical design is composed of the protocols, right? Hardware and protocols. So basically hardware we can divide again as into some of examples. So sensors are some of the examples for hardware that we are using, and then embedded embedded systems, that we are using to collect and process the information in and do other things like transmitting the data. Then we have the communication modules that are embedded in the microcontrollers. Anyway, we can have external hardware communication modules to transmit the data. So communication modules that we are using, the embedded system, or we will say embedded system has multiple things in it. We can say that this is the microcontroller like processing unit, microcontroller processing, and processor. And then we have other communication modules. Likewise, all these components uh, fall under the hardware that we are using for our IoT network. So we can combine these sensors, microcontrollers, and communication modules into one, and we can call it as the as a sensor node, right? We can call the entire unit which contains the sensors and sensors, processors, and communication modules as the sensor node. So this has all these three components. So anyway, this sensor node is composed of this hardware. So basically, it's a combination of hardware and apart from that, we can consider other hardware as well under the word things. So there are like other machines. We can call other machines, like it could be complex or simple machines, other devices, IoT devices that we have. So they are also composed of these sensors and processors. Anyway, like we can basically consider devices also as a single entity that can be called as the hardware. So anyway, like the hardware that is in the IoT system is known as things, and the hardware composes mainly of sensors, microcontroller processor units, communication modules, and if we are considering industry and like large scale situations, we have machines, other devices that also can be considered as IoT hardware. Then we have protocols. We are going to be talking about this in detail. So the protocols or the standard rules that we follow to transmit data are are uh, standard rules that we are using to transmit data that are used to transmit data. We can divide into several layers. Okay, so we will be dividing or we'll be discussing about protocols that come under the layers, which are basically the physical layer, physical and link layer, the physical and link layer, then the network layer, the network layer, transport layer, and the application layer. So we can actually divide the layers, and we can talk about the protocols that we are using under each layer. So for IoT applications, we have specific protocols that we will be using under this physical and link layer, network layer, transport layer, application layer, and so on. So we use specific, types of protocols mainly because we want to ensure the simplicity of the protocol. So we like to use simple protocols for our IoT systems, and we use therefore some specific protocols for those IoT networks. So in the today's class, we will be basically focusing about the hardware and the hardware, different types of hardware that we are usually using in IoT networks or IoT systems. So let's start with the physical devices, right? Let's start with the physical devices. If you have any questions, you can ask. Right, so physical devices, so the hardware, as I said, right? Hardware or the things, as I mentioned, the things we can divide into, as we said, sensors, microcontroller processors, and communication modules, and so on. So we will discuss first about the sensors. I think you're familiar with sensors as well. So anyway, like sensors are like sensors have become part of our lives as of now, right? Sensors are very useful things, uh, and they have become part of our lives. Up to a level where we use it every single day. Even in Sri Lanka, we do have sensor-based systems. For example, when we use ATMs, when we use the ATM, when we go to the food city, uh, where we see the door opening automatically. So wherever there's some autonomous activity, where we are seeing sensors in place. So wherever we have some autonomous activity, we can observe sensors in use. So when we are trying to achieve autonomous or automation in our life, we are using the sensors in those applications, and with that we try to make our life easier. So um, because of that, sensors and using sensors is really useful. And sensors nowadays can measure different parameters, uh, and different are able to sensors are able to different measure or sense. Actually, sensors are able to sense different parameters, are able to sense uh, parameters such as, right? Sensors are able to sense parameters such as, uh, right? Sense some parameters such as uh, they are able to sense the smell. Oh, I don't know about it is also possible because the sensors are able to measure the air quality, and based on that it can detect the air quality, and based on that the smell. So they are able to like capture images about the environment, and therefore the sensors are able to see the environment. Then the sensors are able to smell or detect the air quality, right? The sensors are able to detect the air quality, and therefore they are able to smell the quality of the smell the environment air. The sensors are able to also hear or capture sound, right? Capture the sound, and therefore they are able to hear. The sensors are able to touch, or they are sensitive to the touch, and therefore they are able to detect the presence of some kind of a um, some kind of a object near its sensor. Then it is also able to taste. As of now, according to the resources, the sensors are able to taste or identify some kind of a like some taste from the sensors. So therefore, the sensors are able to see, smell, hear, touch, taste, which means that sensors are almost like humans that can sense any parameter. So, right? So basically, sensors are able to sense any parameter, just like humans. The parameters that are in the environment. So anyway, when we talk about the different types of sensors that are there are basically two types of. We can divide the sensors into two types. We can divide them into passive sensors and active sensors, right? Passive sensors and active sensors, right? So passive means what? Passive means require an external power supply, right? The passive sensors require an external power supply to function, right? The passive sensors require an external power supply to function, and the active sensors do not require an external power supply to function, right? So the active sensors do not require an external power supply to function, right? So the passive sensors require an external power supply to function. Right. We will discuss about the different like sensors under these passive and active sensors, right? So we have multiple sensors out in the market today, and therefore we can see different types of sensors. So we will first talk about the passive sensors and then about the active sensors. So before that, I would like to also mention that the sensors, right? The sensors are able to measure parameters such as, basically they are able to measure parameters related to temperature and parameters related to uh, the flow of the liquid and measure the speed of some kind of a object rotating or object moving, and then it is sensors are able to measure the position of an object and so on. So basically apart from the features that I mentioned earlier, the yeah. All right. Sensors are able to measure physical parameters such as uh, temperature, flow of liquid, and so on. So they are able to measure physical parameters. They're able to measure physical parameters such as the temperature and the level of some kind of water level, air level, or soil level. Then flow of a liquid and the speed of some kind of object, and then position of some object or some kind of a device. So basically these kind of physical parameters can be measured using sensors in general, and we will discuss about each of the types of sensors. So we will go through one of the most commonly used sensors. So anyway, like one of the biggest sensor we are using in our day-to-day life is the smartphone, as you all know. So there are many sensors that are used in the smartphone uh, that constitute of many input parameters, right? So when we take the camera, there's a camera and we have image input. Then we have navigation sensors and light sensors, touch sensors, and then fingerprint sensors, likewise, gyroscope, accelerometer, magnetometer, proximity sensor, near field communication, and humidity sensors. Then RFID sensors, likewise. Many sensors are embedded in the smartphone. So a smartphone is a collection of such kind of sensors. So it's really it has become a really useful device for us as all these sensors keep increasing in the smartphone. So with the like newest smartphone models, we have many sensors embedded in it. So that allows us to obtain more sensor measurements and obtain more information about the phone's position and phones other different parameters of the phone. Anyway, now let's talk about the different types of sensors that are commonly and mostly used by different IoT systems. So when we talk about the passive sensors, as I mentioned to you before, there are many passive sensors that are used, and these passive sensors, they require some external input, right? They require some external power supply. So once we have some external power supply, we can use uh, the uh, uh, sensor, right? So we need the power supply to work with these sensors. And when we talk about these light dependent resistors, the light dependent resistors, or we call as the LDR sensors. LDR sensors detect the light intensity in the environment. So it detects the light intensity in the environment, and these sensors uh, 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 show an output voltage based on the light intensity. So the resistance of the sensor decreases as the light intensity of the environment increases, right? When the light intensity increases in the environment, the resistance decreases in the sensor. So as the resistance decrease, the output voltage uh, is changing based on that. So that is how the LDR basically functions. So LDR is depending it's LDR is depending on the resistance, and the resistance is varying based on the light intensity. So when we talk about the next sensor, we have this sensor, which is the passive infrared sensor. So we call this a PIR sensor. The PIR sensor is able to detect the IR radiation in the atmosphere or in the nearby area. So the IR radiation or the infrared radiation uh, is a, is a radiation that we can observe when we have some kind of a human or some kind of animal in the environment. So the humans, animals, they emit infrared waves. They emit infrared waves. So the infrared waves are actually heat waves. The heat waves, and these heat waves are uh, able to activate this PIR sensor. So the PIR sensor can sense these heat waves, and the heat waves uh, will be uh, will be processed, or the output from this PIR sensor will be a voltage value. So the sensor will sense the infrared waves and give an output as a voltage. So the voltage value will depend on the infrared radiation value. So depending on the infrared radiation value, the output voltage will change. So right, based on the infrared radiation value, the output voltage will also vary accordingly. So uh, and then if there's a if there's a certain, like if we define a certain voltage threshold, we are able to right? When we define a certain voltage threshold, we are able to use this voltage threshold to detect with the presence of a human, right? So, for example, if the output voltage is above a certain voltage threshold, then we can determine that a certain human or certain animal is there around in that nearby environment. Okay, so what happens is that the output voltage of this PIR sensor is used to calculate the difference between the voltage threshold and the output voltage. And if that difference is above a certain value, then the output uh, will be 1, right? The output will be 1 if the difference between the output voltage and the voltage threshold is above a certain value, and the output will be 0. Output will be 0 if the difference is below that threshold. So the output from this PIR sensor will be either 1 or 0 from the output pins, uh, and it will give us whether a certain person is there in the environment or not. So that output the PIR sensor will give. So if you have any questions, you can let me know. When we talk about the smoke sensor next, the smoke sensor is able to detect the quality of the environment or the quality of the air, and it is composed of this kind of a metal, metal based enclosed sensor. So it has a net-like feature. It is able to detect the air quality in the environment. It is used to detect the air quality in the environment. Okay, it is used to detect the air quality in the environment and understand or detect the changes in that in the air quality. Detect and observe the or detect the changes. Detect the changes. Detect the changes in the air quality. Right, the smoke sensor is able to detect the changes in the air quality, right? And the output will be the output of the smoke sensor will be high if the air is not clean, or if the air quality is less. Air quality is less, the output will be high. The output will be 0 if the air quality is up to the uh, output will be low if the air quality is below the if the air quality is high. So if the air quality is high, then the output will be low or 0. If the air quality is high, the output will be low. So based on the output, you can decide whether the air quality is good in the environment or not. So next, the temperature and humidity sensor. I think I don't need to explain that much. It measures basically the temperature in the environment and the humidity level in the environment. So it can measure both these parameters, and it can give the outputs of both these parameters separately. So this temperature and humidity sensor is what right? What the temperature and humidity sensor is measuring those two. Then we have the ultrasonic sensors. The ultrasonic sensors are used to measure the distance. It is used to measure the distance between the sensor and the certain object. Right? Measure the distance between the sensor and object. So what we do here is that the sensor is able to the sensor is able to measure the distance using the time of arrival concept. So basically, the ultrasonic sensors are used here, and the time of arrival concept is used to measure the distance. So, uh, right. So basically, the type of waves or the type of signals that are used are ultrasonic waves and ultrasonic sound waves. So ultrasonic sound waves are used, and ultrasonic sound waves are of a very high frequency, and therefore we cannot hear it with our own ears. We cannot hear with our human ears because there's a very high frequency to this ultrasonic sound signals. There's a high frequency for this signal. So because there's a high frequency, we cannot hear it, and anyway, it can move very far, to a longer range, and it can hit a certain object, and the reflected wave will reach back to the sensor. So the sensor will estimate the time it took for that wave to go to the object and come back to the initial location, and using the time of reception minus the time of transmission, uh, uh, that we will calculate, and based on that difference, the distance between these 2 points will be calculated, right? So we know already the velocity of the wave that is transmitting. If it is transmitting in the vacuum, we can take the velocity of the wave as the light of speed. If it is moving in a certain other medium like air, that also we can take nearly as equal to the light of speed. For other medium, we can decide the velocity using the medium, the effect of the medium as well. So anyway, we can find the velocity of the signal traveling. Based on the velocity and the time difference that we have calculated, you can find the distance between the source and the destination. So that is the basic principle of the ultrasonic sensors. So there's another sensor which is used to measure the distance, just like this. That is the IR sensors or IR distance sensors. So IR distance sensors also can be used to measure distances. IR distance sensors also can be used to measure the distance. IR distance sensors. So IR distance sensors will be using basically IR waves or infrared waves uh, to measure uh, the the uh, angle of arrival, and using that angle of arrival principle, it is measuring the distance between the source and the target, right? So the IR signal is using like the angle that it can measure the angle of arrival, or the angle at which it receives back the signal from the object. Using that, it measures or estimates the object's position. So it uses a similar concept as ultrasonic sensors. It sends the wave and it waits for the reflected wave to come back to the sensor again. So it uses this reflection concept, and also it uses the angle of receiving concept to to measure the distance, right? So angle of receiving concept is used here, right? In here we use in the ultrasonic sensor, we are using the time of arrival concept, right? Time of arrival concept, right? In this ultrasonic sensor case, we use the time of arrival concept. So those are the distant measuring sensors basically. Okay, so in when we talk about the smartphones, again we have another like important sensor that we can consider. So we have the gyro sensor. The gyro sensor is used to measure the angles, measure angle, orientation, measure angle of rotation. Right? Gyro sensors are used to measure angle of rotation. So, right? So the gyro sensors are used to measure angle of rotation. Gyro sensors are used to measure the orientation of a device. Measure orientation of a device. So, like these gyro sensors are placed in the most latest, smartphones such as iPhones and latest Samsung phones, right? So only this feature is only found in the most latest phones that are enabled with the 5G technology and beyond. So so with these phones, actually, we have this option of measuring the angle of rotation and the angle of orientation, right? So based on the north, east, and south and west, we can find in what orientation our phone is placed in. With that information, we can gain other information regarding the the location of our device, our phone, and we can use that data for different applications such as localization or positioning of devices. So that is a useful sensor that is found in smartphones. Apart from that, another like popular sensor that students like to use in their projects is the current sensor, the current measuring sensor, where we use this sensor in a certain circuit, or we use this sensor to measure the current that is flowing through a certain component in a circuit. So the students basically use the current flowing, the current sensor to measure the current flowing through a certain section in the circuit, right? So if they want to measure the current flowing through a section in the circuit, they use the current sensor and place it in one of in between one of the connections between two components, and through that the current sensor get the measurements of the current, and the data is getting collected through a certain IC, and from there the output values are shown from the output pins. So the current sensor is another popular sensor that is used by students in their projects. And then, as I said, the gyro sensor that I mentioned earlier, this is also a sensor that is used by students for projects. And I have seen the gyro sensor is used for, robots, robot arm systems, and, like, like wheelchairs, automatic wheelchair projects. Likewise, where you want to rotate a certain object and measure the rotation, you use gyro sensors. Then we have the Hall sensor. This is also one of the sensors that are useful for several applications. This is basically used to measure the magnetic field in the environment. So this is used to basically detect the magnetic field in the environment. The magnetic field in the environment. Right? So the magnetic field in the environment we can measure using the Hall effect sensor. We call this Hall effect sensor. So the Hall effect sensor will detect the magnetic field in the environment, and it will give the amount of magnetism around in the environment. So once we move a certain magnet towards this sensor, that sensor will detect that and give out different output voltages compared to the normal output voltages, and show that there's some magnetic field in the environment, right? So this is helpful for us if there's a high magnetic field out in the environment, and to detect that, this sensor is important for us. So Likewise, there are several sensors that are popularly used by people in their projects, and basically use that to measure certain parameter. So I think we discussed mainly about the passive sensors. We did not discuss about the active sensors. So now I think we will discuss about the active sensors that I mentioned earlier. Right? Do you have any questions so far? So the thermocouple is one of the examples of the active sensors. So the thermocouple is a sensor which can measure the temperature of the surrounding environment, and based on the temperature in the environment, it can give an output voltage that is related to the temperature, or that linearly varies with the temperature. So the thermocouple is able to detect the temperature and give out a voltage that varies with the temperature, right? So the voltage that it gives as output is related to this temperature that it detects in the environment. Okay, so this thermocouple is an active sensor, and we don't need to give external power supply. So the thermocouple is like built with the certain specific materials that allows it to get the temperature readings and convert it to a voltage value, right? So there's another sensor which is similar to thermocouple, which is known as piezoelectric sensor, right? Piezoelectric sensor, which is also an active sensor. Piezoelectric sensor is also an active sensor which is used for similar applications that that are concerned with the uh, generation of electricity or generation of voltage based on the amount of energy or energy available in the environment, in the nearby environment. So the piezoelectric sensor is another example of the active sensor. Thermocouple is a example of the active sensor. So the output of the thermocouple will be in the milliwatt range or very low voltage range. So the output will be like low in the low voltage range, and therefore in order to get some a measurable output, we will be amplifying it through certain amplifier, and construct the signal, construct the voltage level to a uh, acceptable voltage level, and then feed it into the systems, or some kind of system that measures that data, right? So this is a PLC system. So the PLC system wants to know the temperature of a certain of the environment. So that temperature data will be fed into this PLC environment through these sensors, through this thermocouple sensors, and the transmitter that amplifies that thermocouple output and provides that as a like a considerable voltage to the PLC. And so the PLC will receive temperature data through the thermocouple, right? So that is basically regarding the thermocouple. So do you have any questions? Do you have any questions? Uh, so let me know if you have any questions related to the project. So, related to the assignments that I have given you, right? I will stop this recording.